Welcome to Chapter 15, C++ as a better C, introducing object technology. So as you can see, there's a lot of material in this particular chapter. We're only going to scratch the surface here just to give you an introduction to what C++, what object-oriented programming is, and how it's so different from the C language that we have covered this semester. So this is a quite significant chapter, and I would say that in order to really just get an introduction to C++, you need to go through at least not just chapter 15 but also chapter 16. Some of the materials that are early on in chapter 15 are related to stream I/O, and you already know some of that. The use of C-in and C-out streams, using endl to end a line instead of /n when dealing with streams. So some of this stuff we covered very early on when we were covering C. So those were actually topics that belong to C++. Okay, so C++ introduces two additional programming paradigms. One is called object-oriented programming, and we'll talk more about that today. And the other one is generic programming, and you'll really have to get more into C++ to get to appreciate that. But the emphasis in object-oriented program, not just in C++, but also other object-oriented programming languages, is to write code that is versatile enough that you can use it across multiple projects. So software reusability is really a big theme in object-oriented programming. Object-oriented programming, or short OOP, OOP, involves classes and objects. A class is used to describe something in the real world, and that can be something tangible, something intangible, can be events even, and I'll show you some examples of that. Can be occurrences, things, external entities, roles, organizational units, places, structures, whatever makes sense in the context of the problem that you're trying to solve, the program that you're writing. So a class describes the structure and behavior of similar objects. Sometimes it's also described as a template or a generalized description, a pattern, or a blueprint for an object. So kind of like the difference between a class and an object is kind of like the difference between a house, which is an object, and the blueprints of that house. So you'll have one blueprint, but you can make many houses using that blueprint. So in that sense, an object is also called an instance of a class. Objects have their own, each object of the same class has its unique identity, state, and behaviors. Well, behaviors are actually not that unique, but identity and state definitely. The state of an object is basically the set of values of its data fields, or its member variables, the variables inside that object. Sometimes they're also referred to as properties. Now, the behavior of an object is defined by a set of functions, and when we talk in the context of object-oriented programming languages, we use another term for functions that you should now become familiar with, and that term is methods. So the functions that we have been, what we have been calling functions so far, another term for that is also method. And so an object is basically a bundle of software, a software bundle that includes some variables and some related functions or methods that can be used to operate on those variables that are part of this software bundle that we call an object. And here are a couple of examples to help you think about the difference between classes and objects. So for example, you have a type of occurrence, let's say an alarm. And so you could define a class called alarm, and one instance, one object of class alarm would be a fire alarm. Among things, a car, for example, could be defined as a class. And a Ferrari 360 would then be an object of type of class car. External entities, door, for example, could be a class, and a fire door would be an object of that class. Among roles in an organization, for example, teacher could be a class, and objects of type teacher could be, well, different teachers that you have in that organization. So maybe someone called Muhammad, someone called Hassan. And organizational units could be defined as a class. For example, department could be a class. And then the different departments could be represented as different objects of type of class departments. For example, CS, IT, IS. And not only that, classes can have relationships between them. So for example, you could have a class called bicycle, another class called teacher, and another class called book. And you could represent them in your program as different classes. And one object, and these different objects in the real world do have relationships to each other. For example, a certain teacher may own a bicycle or may read a book. So you have these actions, these relationships going on between objects in the real world, and this is something that can be modeled in object-oriented programming languages. Now, if all of that seems a little abstract at the moment, don't worry, I'll show you some very basic code that explains how all of this happens, what a very basic class in C++ looks like. So, but before I get to the code representation of a class, there's also another representation that is called UML, class diagrams or object diagrams. And this is a visual representation of classes and objects. So, visually, a class in a UML diagram is represented as a box with 3 compartments. The one at the top, the topmost compartment, contains the name of the class. In this example over here, that the name of the class is student. The middle compartment contains all the data members of that class. In this case, it is a string called name. And then the bottommost compartment contains a list of operations or member functions and methods. In this simple example, we have 2 methods, functions. One called getName, which, as the name says, returns the value of name, that data member that we have in here. So it returns a string, and that's what's represented by this colon followed by string. And then we have another method called setName. If you want to change the name value of the name member variable in an object. We can have a function for that. Now you can see the actual code of these methods is not shown over here, but at this level we don't want to show that. We are not showing that. And just like you can represent a class using a UML class diagram, you can also represent objects or instances made from that template. And that's what we've done here at the bottom. So we have 3 instances over here: student object S1, student object S2, student object S3. And the values of their name member variables, name data members, are, for the first one, S1, it's Ahmed. The second one contains Ali. The third one contains Sohail. Now, there are 2 kinds of classes, kind of like there are 2 kinds of functions that we've seen in C. There are the functions that are part of the standard library, and in C++, the corresponding thing we have are C++ standard classes. And the advantage of having them is, of course, that you do not have to reinvent the wheel. If there is already an existing class in the C++ standard library, you should use it. Don't make your own. It's already tested, verified. You should use that. And that's why it is very important for you to familiarize yourself what's in the standard library already, and use those classes whenever you can. However, sometimes your needs will be so specific that the exact class that you need won't be available in the C++ standard library. In that case, you have to make your own, kind of like we have been writing our own functions to solve some problems. So in the same sense, we can have programmer-defined classes. And this is kind of what that looks like, just very broadly. This is what a class in C++ looks like. So we start with preprocessor directives. We're already using those in C as well. Usually we put the comments describing what the class is and does before we put the code for the class. Then we have a new keyword, class, and that's what's shown over here, and that's followed by the name of the class, and that's followed usually by data members and methods. But there's more detail to that, and we'll get to that. But important thing to note here is that there's at least one new keyword that you use when you do object-oriented programming. C++ can also be thought of as an improved version of C, and that's basically where the name comes from. So C++ is basically C with classes, and the plus is actually representing the increment operator that we've been using. So it's kind of an enhanced, improved version of C. That's what the name C++ means. As for the developer of C++, that is a Danish computer scientist by the name Bjarne Stroustrup, who developed C++ while working at Bell Labs. Now, in addition to data members inside a class, classes also have local variables. Those are the variables that are declared inside functions. Those variables, just like the local variables in functions we've used before in C, those local variables are only visible and accessible inside the functions that they're declared in. So, significantly, local variables cannot be accessed outside of those functions. And when the call to a function terminates, the values of local variables are lost. Objects have attributes, and like I said, those attributes exist for as long as the object itself exists. Member functions are usually how you access those data members of a class and how you manipulate, update, change the values of those data members. Each class, each object of a class, if you make multiple objects from a class, template class, each object has its own copy, its own attributes, its own copies of those data members. So data members are declared inside the body of a class. And each instance, each object of a class has its own data members. Here's a very simple example of a class in C++. Now another thing, and I won't go into that, is that C++ has its own header files, and an easy way to figure out that the header file that you're using is from the C++ standard library is by looking at whether it has a .h or not. If it has .h, it's basically a C standard library header file. If it doesn't, like you see over here, iostream, string, then missing those .h at the end, .h extensions at the end, then we're looking at C++ code. So I'm not going to even run this code for you. I'm just going to describe what's in here. So what's happening over here is we are defining a class called gradebook, and it contains some items that are public, that will be accessible, that will be visible, accessible from outside the class. And among those are a function called setCourseName, which takes as argument a string called name, and inside that function, name is assigned to course name. What is course name, you may ask? Well, I'll skip ahead and you'll see that course name is one of those data members, is the only data member of this particular class. And as you can see, before that we have another keyword, private : private. Private meaning that anything that is put here after the private keyword is not accessible, is not visible to code outside of this class. This line over here is where the gradebook class code ends. And then we have another function over here called getCourseName. What it does is it simply returns the current value of string of member, data member, string, course name. And then we have a third function over here called named displayMessage, and all that does is calls cout, the output stream, prints out welcome to the gradebook for new line, and then it calls getCourseName, which returns the course name data member. So that gets printed over here, followed by an exclamation mark and new line. Notice also that at the end of a class definition, we have a semicolon over here. Okay. Now, let's see how do we use this class. And like in C, program execution begins in the main function. And what we do over here is we begin by declaring a string name of course. String, as you see over here, is kind of like a new data. We're not using character arrays anymore. String is actually a class of itself, by itself. But for the moment, think of string as a new data type. And what happens next on line 41? We declare an object of type gradebook, the class that we just looked at up here. And we call that object myGradebook. And you can see this looks exactly like how you would make an instance, how you would declare a structure or even a variable. And we call cout in the main function, and we print out initial course name is, and then we call the get course name function of the myGradebook object. And then on the next line, we have another cout statement. Please enter the course name, new line, and we have a getLine function. This is basically reading from cin a string and putting it in name of course, which is this local variable name of course. And we pass name of course to myGradebook using the setCourseName function as an argument. And just to see if name of course passed through the setCourseName function, if that has actually been written into or has been stored in the myGradebook object, we call the display message function of myGradebook. And this is what the output is going to look like. So initially, nothing. Then we ask for the name of a course. This is what's happening here on getLine. We type in this as input, CS 101, Introduction to C++ Programming. And we call cout new line, and we print out, we display the message returned by myGradebook. And that is welcome to the gradebook for, and then it prints the value of string course name inside the object myGradebook, and that is CS 101 Introduction to C++ Program, exactly what we specified over here. You can see that there's another new keyword to see, private. So if you declare something private, you basically limiting access to it to code that is inside, to functions, methods that are inside, that belong to the class. By default, everything, all the code that you start writing inside a class is private. This is also called an access specifier. However, we began our class with the access specifier public, again, because the default would have been private. So we began with public, made those functions public so we can call them from outside an object of class gradebook. Member variables, data members, we usually try to keep those private. If anything, if any code outside of our object needs access to those data members, those data members should be accessed using member functions, which we will write ourselves. So this way you get to control the type of access to data members of your class. Like I said, default access for class members is private. If you want it to be anything else, you have to specify that by using the public keyword. And as long as you don't add the private keyword, everything under that, under public, will remain public. So for this particular class that you just saw, this is what the UML class diagram for that would look like. Class gradebook, data member, a string called course name, set to private, that's what the minus sign in front of that means, and 3 functions that are public. Public, how can I tell that? From the plus sign in front of those function names. And get course name returns a string, and I can tell that from the data type provided after the colon over here. Now there are some other special types of functions that we usually add to classes called constructors. Constructors are functions that are automatically called whenever you declare an object of a certain class. These are special member functions, and they must have the same name as the name of the class. Constructors are different from other functions also in the sense that they cannot return a value, not even void. Normally, constructors are declared public. Now, C++ automatically calls a constructor function for each object that is created. And you can have multiple different types of constructor functions. The one that is called automatically, if you do not specify which one to call, the one that's called automatically is called the default constructor, and it does not take any parameters. If you want to pass some information to an object at the time it is being created, you need to write and explicitly write your own constructor for that. And here is the same example of the gradebook class, but this one with a constructor, an explicit constructor added to it. And you see that here in the yellow section, you can see we have added a function to the gradebook class with the same name as the name of the class, called gradebook. And this one takes an argument, does not return any value. And what it does is, this is what the next line on line 15, what that specifies. It initializes the course name data member to the value of name that is passed as an argument over here. Nothing else is happening. If there's anything else you want to do at the time an object is created, that code goes in here. Since there's nothing else for us to do, line 17 is empty. Other than that, we have some familiar functions: set course name, get course name, and display message. Those are the same functions we had in the previous simpler version of this gradebook class. And here's a demo. And of course, then in the private section of the class is the string data member course name. So test run this. Let's try this out. And here we have a main function again. And in it, we initialize, declare 2 objects. Create 2 objects of type gradebook. The first one we call gradebook 1, the second one we call gradebook 2. And see over here that we are also providing an argument along with that. At the time, we are creating gradebook 1, gradebook 2 objects. And this is basically the new constructor function that we added at work. This string that is being passed over here and the string being passed over here is what is received as string name, which will be used to initialize course name. So instead of making the user ask for input at the command line, you can immediately initialize member variables of an object by passing them as arguments in the constructor function. And just to make sure that the initialization succeeded, we call the get course name functions of both objects and display them using a call to the cout statement. And if you run this, you get something like, you get exactly this for output.